Okay. So here we are, fellow students. We are about to discuss about the whoosh. Okay. We are here to discuss about the Castigliano's theorem or method. So Castigliano's method or theorem is a deflection of partial derivation of strain energy with respect to fictitious loads. So here we have a simple truss given an area of 0.0001 meter squared and a module of elasticity which is equal to 200 times 10 raised to 6 kilonewton over m. So the problem would be determine the vertical deflection of joint P using Castigliano's theorem. So here, given the figure, we have a 50 kilonewton in directed downwards at point P, and this is a special triangle since it has 30-degree and a 60-degree triangle.
Wow.
With the given distance from point P, lever arm, I mean 2 meters. So first, we are going to do a free body diagram. In drawing the free body diagram, we would like to know the values of y and x for us to solve the two supports. So in solving this, we would use trigonometry.
Wow.
So solving for the distance x and y, tan 60 would be equal to y over 2. So y value would be 3.464 meters, while tan 30 equals x over 2 would be equal to 6 meters. So now, since we have the lever arms of each unknowns, we can be able to solve the support reactions. So first, summation of moment along A. Oh wait,
Wait a minute.
here, if you have noticed, the 50 Newton was not seen here because at our problem we are looking for the vertical deflection of joint B. So we assume the fictitious load here at joint B vertically going down. You might ask why we remove this 50 kilonewton. The answer would be because it coincides with our fictitious load. So later you will be able to understand why.
Wow.
In solving the support reactions, summation of P is equal to 0. Summation of M with respect to A at point A is equal to 0. Counterclockwise is positive, so P. So in solving this, we will get the value of CV, which is equal to 0.75 P. So since we are able to solve for CV, it is easier for us to solve AV using summation of forces vertical. So upward would be positive, assuming that upward would be positive. AV minus P plus CV is equal to 0. So having this formula, we would get a value of AV is equal to 0.25 P. If you would notice, all the bar forces would be in terms of P. That's just normal.
Wow.
So here in joint A, we are going to get the value of AB. You can get the value of AB by this formula. Summation of vertical, which is equivalent to 0. So we would get a value of negative 0.5 P. since it is negative, we would assume that it is a compression. Next step would be a joint B. So remember, um, we have assumed that the fictitious force would be downward. So according to this joint, we could be able to identify or solve for the value of BC. So BC, um, by the formula summation of forces along X, we would get the value of BC is equal to negative 0.866 P, which we assume to be compression since it is negative. At joint C, again, use of summation of forces along X axis or horizontal, we will get the value of AC, which is equivalent to 0.433 P, which is tension. So remember that the value of P here, this P is equal to 50 kilonewton. So here we're going to substitute here. So here AB, member AB, BC, AC. So this is the bar forces with respect to P. These are the solved values, and this is the derivative of this one. So the P would be cancelled out, and here the next table would be having the length in terms of meters. So here this is not given. What we're going to do, we're going to solve it using Pythagorean theorem, since it is a right triangle. You see, right triangle. So using Pythagorean theorem, we would be able to get its hypotenuse, which is AB and BC. So here, using Pythagorean theorem, we would get a value of 6.9282 meters, while BC would get a value of 4 meters. But here, we'll just have to add the length of X plus 2 meters, which is this one. So next, in solving this, which is very necessary, this is the final step in solving our vertical deflection at joint B. So here we have the value of S, which is this S, L, which is the length, A, which is the area, E, which is the module of elasticity, multiplied by the first derivative, with the first derivative. So here, in substituting the values, remember that the P is equal to 50 Newton. So in substituting P here, you would get a value of 0.0433 for members AB, and for member BC, we would get a value of 0.75499. And for member AC, we would get a value of 0.3749. So the final step would be adding it up, because we are solving for the vertical deflection. These are the vertical deflections at joint B. So just going to add up the solved answers here, and we would get a sum of 0.1557945 meters. So therefore, the vertical deflection at point B is equal to 0.111557945 meters.
Oh my God! Wow!
So I hope you understand, and thank you for listening.